Part 2, hints for 3 homework questions. Question number 21, 22, and 24. All right. First, question number 21. So this question, actually we did a similar question before. So here I like to give you the reference. Some students may not remember that example. So that example is very close to this one. So if you study that example and understand well, you can easily solve this problem. All right, so that is Module 3 and a part D, D.3. Look at the D.3, that video. Okay, try to find it and watch the video, D.3 part. So at that time, I show you how to solve the first order linear recurrence relation. So it's first order linear recurrence relation, right? So that one. At that time, we use a simple example. So let's recall that simple example. So that example comes from the Tower of Hanoi problem. Hanoi problem, okay? Tower of Hanoi problem. So the recurrence relation we worked there, C of 1 equals 1, and the C of m equals 2 times C of m minus 1 plus 1. And here, although the coefficients of the recurrence relations are different, but you can see the structure very close. So E sub 0 equals 0, E sub n equals 5 times E sub n minus 1 plus 4. Structure very close. All right. So here, let me just explain the basic steps. Usually here we need to use 2 steps. Step 1, we need to do conversion. We need to convert a non-homogeneous equation to a homogeneous equation. Okay, so here, this term, plus 1, make it a non-homogeneous. Okay, plus 4, non-homogeneous. Okay, The question is, after we do some substitution, variable substitution, for our new equation, the homogeneous, the constant part is gone. So we derived a new recurrence relation without non-zero constant term. So you just look at the video, okay? The video for D.3 of module 3. So then step 2, very easy. Solve the non-homogeneous. Sorry, this time, because we converted to homogeneous. Solve the homogeneous. equation easily. Yeah. Easily. Yeah. So you watch the video, you can see it's pretty straightforward to get a solution formula. Yeah. So after that, then you go back. Yeah. So you have variable substitution. So then you can write, get the final solution. Okay. Yep. So you just studied that example, then the solution is pretty obvious. Okay, so not very hard. Yeah. The next question, number 22. Yeah. So for this one, boundary search problem. Yeah. So I hope you still you can find appropriate reference location. Yeah. So here I can tell you module 4. Module 4, part C. Yeah. Module 4. Okay. Part C.3. Yeah. At that time, remember I did example, did an example for n equals 7. Yeah. Because this one corresponds to a complete binary tree. All right, yeah. Here, the biggest change. Here, n equals 15, we also get a complete binary tree. Yeah. But important change, we have a condition. Our condition, the given key appears in array between 5th and the 12th element. So that condition, we should use it in a correct way. Yeah. Here, let me draw a simple diagram. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah. The range for the given key, lower bound, upper bound, between these 2 points, but inclusive. So the key is in this range. All right, yeah. So now, the main question that many students could get wrong. Yeah. So the main problem here, main understanding problem, is like this. Okay, all right. So when we construct a binary tree, what data do we use? Okay, so the data to be used for building a binary tree. Okay, yeah. So we need to understand this point well. So there are two ways that people usually take. Yeah. The first one, use the whole array. That is the array elements x1, x2, x15. Yeah. But the second case, the partial array. That is the array elements in the given range. So x5, x6, x12. Okay? Yeah. Because many students, when they see the given key falls in this range, so they may feel when they build the binary tree, they should use the data in this range. But the second interpretation is incorrect. Okay? Yeah. Do not use this way. Okay? Yeah. The first what is correct. The whole array is correct. Constructing binary tree. Yeah. Why? So here, let me explain it. Yeah. Let me explain it. Okay, all right. So in the binary search, implementation, so we apply the binary search on the whole array. Okay? Yeah. So in general, we apply it on the whole array. All right, so now how do you add the given condition here, right? Yeah. All right, so although the given key falls into certain range, but this condition is hidden. Our understanding for this condition is hidden. Hidden means nobody knows it. Okay? It happens. So this condition happens at the end. At the end, when we do several experiments, then if we do statistics, we notice that the key, all the given keys fall into this range, but when we do the data processing, we do not know it. So we cannot assume the condition is known, so we can modify our binary search. No, we cannot. So we do not want to modify our binary search. We just apply our general binary search on the data, okay, in a blind way. So in a blind way, yeah. But the data has some hidden property. Yeah. So our understanding is the data has some hidden property. This hidden property is known after you complete data processing. Okay? But you already completed data processing, right? Yeah. So based on that understanding, so you should use the whole array to build your binary tree. Okay? So not a partial array. Yeah. Because you do not know. You do not know your partial array can cover all the given keys, right? Yeah. All the search keys. Yeah. You cannot. Okay? Yeah. So you still, to be safe, you want your whole array to cover all the search keys. But a set of search keys happen to fall into certain range. That understanding. Okay? Please use this understanding to answer this question. All right, so the next question, number 4. Yeah. So for this question, so I designed this question in order to check your understanding of an important sort algorithm in module 4, that's merge sort. Yeah. Targeting this question is designed targeting the merge sort. Okay? All right. You may not be able to see it clearly, but so if we look at our data, so our data has this property, 2 ordered subarrays. That's the main property of our data. 2 ordered subarrays. Okay, yeah. The first one, x1 less than x2 less than x3, and the second one, x4 less than x5 less than x6. Yeah. Okay. So now our goal, we want to find the third largest element for the worst case. The goal. Okay. Yeah. How to solve it? Yes. So the main idea, the main view. The understanding. How do you understand this question? Yeah. The main view. Yeah. First, although this question related to the merge sort, but do not apply the merge sort on it to sort it. Yeah. Because if you apply the merge sort, you sort it. So the first thing is, do not apply the merge sort, because you will do more than necessary work. So do not apply the merge sort directly. Okay? Yeah. Because too much work. Yeah. So we want to save as much as we can. Okay, all right, yeah. So, but we can see something related to the merge sort. Yeah. First, the data. So data here, 2 ordered subarray. Can you see our situation here closely related to our merge operation? Okay, yeah. So closely related to the situation for the merge operation, right? Yeah. All right, so but here, I hope you recall the merge operation. How do we apply the standard merge operation? Okay, yeah, so here, recall the standard merge operation. But here we need to use a modified merge operation. Yeah. So not standard, modify. Okay. So what we're doing here, we should use a modified merge operation. Yeah. So how do we modify the operation? Yeah. Because the standard merge operation, we process the data from left to right, right? From left to right. Okay, so then we put elements in place from smallest to largest in ascending order. Yeah. So that's what we did in the standard merge sort. But here we modify in this way, the opposite way. So we process data from right to left. The reason is simple. From right to left, the first time we put the largest in place. Second time, we put the second largest in place. The third time, we put the third largest in place. After that, done. Do not do the remaining work because the third largest already, this is our goal. Okay? Already it's goal. We reached the destination. So we should stop. Okay? Yeah. So think about this new view. If you can understand this view well, then you can solve this problem in a perfect way. Okay? All right. So that's the 3 questions for part 2. Then we have our last question, question number 25 in part 3. So I will explain it in the following videos. Yeah, probably I plan to use 2 videos. The first one, the simpler part. The second video for the relatively hard part. All right, so that's it.